Everybody, Mr. Covey here, and today we're going to be talking about something really important, which has to do with the order that you should perform transformations in. Okay, and this is something that's actually important. At first, kids are like, "That doesn't even matter. What are you talking about?" So first, I want to demonstrate to you, convince you fully that the order that you do transformations in actually matters. Okay, so we're going to run through a quick example here together. So let's consider you got the graph of g of x down here. Cool. And we're going to consider this new function, which is 2 times g of x minus 3. I hope you're getting good at this transformation stuff now, and you're like, oh. That times 2 is a vertical dilation by a factor of 2. It's multiplying, so it's a dilation. It's on the outside, so it's vertical. That minus 3 is also on the outside, so it's also vertical, but it's subtraction and also down 3. So you're like, those are the 2 transformations. Duh. Now, both of these transformations are vertical, and so it actually matters what order you do them in. So I want to first perform them in the order that we wrote them down in part A. Okay, so you guys remember how to do this. A lot of you guys, I think, are using this table technique. I think that's a good technique. Okay, so let's make a little table with the coordinates. Okay, and let's do these transformations. These are both vertical transformations, so they're both affecting the y coordinate. A vertical dilation by a factor of 2, well, my y's are just going to get twice as big. So let me make that table. Check. Down 3, my y's are just going to get subtracted by 3. Again, my x's are staying the same because these are vertical transformations. Here is my ending table. I'm going to graph those points over here. That certainly looks plausible. It's definitely been stretched vertically. It's definitely moved down. Cool. However, I just wrote those transformations down in that order. Let's pretend like I wrote them down in the opposite order. Down 3, and then the vertical dilation by a factor of 2. Okay? So we're going to have the same starting table. That's the same. But let's do the down 3 first this time. So let's take this and make a new table that's down 3. In other words, let's make the y's 3 less first. Okay? I made all the y's 3 less, and now we're going to do a vertical dilation by a factor of 2. So I'm going to multiply all the y's by 2. Again, I'm doing the same 2 things. I'm just doing it in the opposite order. Okay, let's take all our y's and multiply them by 2. Okay, I did the same 2 transformations. The graph should look the same. Or should it? Let's plot these new points and see what happens here. Oh, that green graph is straight up a different graph than the red graph. I did the same 2 transformations, but somehow I got a completely different answer. Why? Because I did them in a different order. And you guys know that the order that you do transformations, just like the order that you do operations in, matters. You've known this forever, okay? If you're like, wait, why does the order matter? Just pause for a second. Turn on your brain. How do you do 2 times 3 plus 1? What do you do first? Well, you do the 2 times 3. And then you add the 1, and you get 7. If instead you did the 3 plus the 1 and got 4, and then did 2 times 4, well, you'd get 8. That's just 2 operations. The order that you do them in matters, okay? And which way is correct? A lot of you guys probably would do it this way without even thinking about it. For the same reason that you would do it this way, which is the correct way with numbers. And that's because it makes sense to do the multiplication first, okay? So these graphs are not the same. Which order is correct? Doing the multiplication first and then the addition is the correct way to do it in this case, okay? So if you're talking about vertical transformations, what do you do first? You do the multiplication. What do you do second? The addition. Why? Because you always do multiplication before addition. Go back to first grade. You guys are probably in preschool when you learn that. You're so smart. How do you remember it? It's the order of operations. It's good old-fashioned PEMDAS. You do multiplication, and then you do addition. You do the stretch, and then you add. Okay? In other words, you do the multiplication, which in transformation language is the dilations or the reflections, because the reflections are just negatives, which is the same as multiplying by -1. So you do the dilations or reflections first, and then you do the translations, the shifts, second. Okay, easy enough. How do you remember? PEMDAS. Here's the weird thing. Horizontal transformations. Horizontal transformations are backwards. They're weird. They do everything the opposite of what you think. And if you have that idea in your head that horizontal transformations are backwards, weird, the opposite of what you think, then that applies to this idea as well. They're so backwards crazy. What do you do first? You do the adding first. In other words, you do the shift first. You do it kind of like you did this one. Only if it's horizontal, you do it that way. You do the adding, the shift first. What do you do second? And then you must do the multiplication. In other words, you do the dilations or reflections second. How do you remember that? You remember it's backwards. It's reverse PEMDAS. Okay, that's how I remember it. Okay, there's different ways that different teachers teach this. Yeah, Mrs. Lemke, she might teach it some old school way. You know Mrs. Lemke. But that's the way I like to think about it, okay? I'm just making fun of Mrs. Lemke. Cool. So it works backwards, just like the individual transformations for horizontal transformations are backwards. The order that you do them in is also backwards. Okay? This is not in your note packet, but I just want to jot down a couple examples to make sure we're clear. Okay, so for these three, I want to list the transformations, and from now on, for the rest of your life, you need to pay attention to the order of the transformations. So here, I have two numbers that are both on the outside. They're both vertical transformations. One of them is a vertical dilation by a factor of 3. The other one is a shift up 2. Do I do the multiplication first or the addition? Well, it's vertical, so it works normal, meaning I do the multiplication, the dilation first, and then I do the translation. And I like to put that little 1 and 2 there to help me remember the order. Okay, next one. I have 2 transformations. I got this -3 on the inside. That's going to move it right 3, remember. It's horizontal, it's on the inside, and it's minus, but it works backwards, so it's right 3. That multiplication by 4, or excuse me, by 5 on the inside is going to be a horizontal dilation. Okay. By a factor, not of 5, it's not 5 times as wide, by a factor of the reciprocal of 5, 1/5. Okay. Now again, you'd think you'd do the multiplication first, and then the addition, but wait, it's horizontal, and horizontal stuff is backwards. So what do you do first? Well, you actually do the right 3 first. Then you do the horizontal dilation. Okay. Backwards. Reverse PEMDAS. Last one here, we have a vertical dilation by a factor of 3. And then we got a +2 on the inside. That's going to be horizontal. It's going to be a shift. It's not right 2, though. It's left 2 because it's backwards. Now, one of these is vertical and one of them's horizontal, so which one do you do first? It doesn't matter. Why does it not matter? You're like, I thought you just got done saying all the transformation order stuff matters. It doesn't matter because one's vertical and one's horizontal. So you could do it in that order. You could do it in this order. It doesn't matter. And the reason it doesn't matter actually makes a lot of sense if you think back to the table stuff. So like the order that you do the stuff matters if both things are affecting the same coordinate. In other words, if you have 2 things that are affecting the y coordinate, you have 2 vertical transformations, it matters whether you multiply first or add. But if you have one thing that's changing the x's and one thing that's changing the y's, they don't interact with each other. They don't interfere with each other at all. So the order that you do them in doesn't matter. It doesn't matter whether you multiply the y's by 3 first or subtract 2 from the x's. Like one of them has to do with the x's, one of them has to do with the y's. They're not interfering with each other. Okay? So these little rules that I laid out in this table only apply if you have multiple horizontal transformations or multiple vertical transformations. Let's jot that down. Okay. So that's the only time this really comes into play. I'm going to do one more really tricky example with you guys, just to illustrate one final. Okay. So last example here, just jot this down somewhere. If you could take a second and write down the transformations that are happening here, and then try and figure out an order. Note that this is like putting everything together because I got 4 numbers here. Each one of those 4 numbers is going to do a different thing. Try and figure out the 4 transformations and figure out a possible order. Go ahead and pause and give that a try. Okay, so here are 4 transformations. I hope that wasn't too bad. A vertical dilation by a factor of 3, check. -1 on the outside, that's down 1. +4 on the inside, that's left 4. Multiplying by 2 on the inside of the parentheses is a horizontal dilation by a factor of 1/2. Now let's talk about the order, okay? So in terms of the vertical transformations, I need to do the multiplication before the addition or subtraction in this case. In other words, I need to do this. I need to do this. Has to be like that. For the horizontal stuff, I need to do the addition, I need to do the shifting, I need to do the translation left 4 first. And then I need to do the dilation second. Okay, so I need to do this before this. But then when you put it all together, if you're like, well, what do you do first though? Like I understand that you want to do green before black and red before pink. But beyond that, it doesn't matter. You know what I'm saying? Like you could do 1, 2, 3, 4. That totally works. You could do 1, 2, 3, 4. That totally works. You could do 1, 2, 3, 4. Totally works. All that matters is that you pick an order where green happens before black and red happens before pink. Because these two interact with each other and they affect your x coordinates because they are horizontal transformations, and these two interact with each other because they are vertical transformations and affect your y coordinates. That's as hard as it gets, guys. I know this is even a little complicated, but that's it. That's all 4 transformations all mushed into one problem. Don't worry, we're going to practice this a lot. Thank you guys for watching. That concludes this video.